Let's say that you had a latch that you wanted to stay closed. Closed until you pulled with, I don't know, let's say a couple of pounds of force. And once you've pulled on this latch with a couple of pounds of force, then you want it to break free and open. There are a variety of reasons that a designer might want to incorporate that kind of mechanism or feature into a part. So if that was the case, how would you do it? How could you use just a simple piece of hardware that would allow you to passively close something until some threshold of force or resistance had been applied, at which point the latch would open up? What would you use? Now, realistically, there are probably a few ways of doing that, but one of the easiest ways that comes to my mind is using magnets. And there are different types of magnets. We looked at this example earlier in a different lesson. This is your typical cheap little refrigerator magnet clip. So there's a magnet right there that you can stick to the side of the refrigerator. I've found that in our work, which is predominantly mechanical design, machine design, some consumer product design, we haven't used those magnets as much. They're not very strong, and for things like a little clip like this, they're great and work well, but we sometimes want a little bit more powerful magnet. And what we've used often, they're called rare earth magnets or neodymium magnets. This is an example right here. They have a very brilliant finish. I believe it's a chrome plating on this, so it's a very bright, brilliant finish. Whereas some of these cheaper magnets, and to be honest, I don't know what these ones are made out of. It's a darker matte color, and there are a myriad of different sizes and shapes. So like there's this tiny little cylinder right here, a big pancake flat size like this. One of them I really like is this style here. Let's see, I need to set down the other magnets to prevent this one from flipping around. And this one has a little countersink feature in it, so it's like that conical recess right there. And on the other side, it's flat. And the reason this is really useful is because you can use that countersink to put a flathead screw in there and hold it in place. So if my finger was, I don't know, an aluminum part, let's say, and there was a threaded hole going through my finger right underneath the hole of this magnet, I could take a flathead screw and drive it right in there and hold the magnet in place very rigidly, very firmly. That magnet is not going to go anywhere. And then if I get a second magnet like this one, oh, there you go. They stick together. Whoops, there we go. They stick together just like that. So if you can kind of visualize in your mind that there is the countersink in both of these magnets, one in this one and one in that one, and there would be a screw. You'd see the screw head, or I'm sorry, the end of the screw sticking out on this side, and then on the other one you'd see the other end of the other screw sticking out over here, and they'd be mounting or joining these magnets into two opposing parts. So maybe this is like a base plate. This magnet is held in a base plate. This magnet is held in a latch that rotates. And when that latch, gets close to this magnet, boom, they stick together, and they're held together with, this one probably is not 2 pounds, but you can get certainly bigger sizes than this, 2 pounds, 10 pounds, whatever. Well, up to some limit, but typically if you're doing some kind of latch mechanism, you only want a couple pounds. Anyway, these will stick together, and you can pass it. It's a passive joining, right? You can pull it apart with enough force. So I guess one more thing to talk about is that magnets will not stick to anything, right? Magnets don't stick to plastic, and they only stick to some metals. For example, aluminum. This plate right here is aluminum, and magnets. Do magnets stick to aluminum? Let's find out here. All right, so we put that magnet on. Doesn't look like it. Nope. Magnets do not stick to aluminum, and that is because why? Does anyone know why? What does aluminum lack that a magnet needs for magnetic attraction? It's an element. It's called iron. Magnets only stick to or are attracted to ferrous materials, that is, materials that contain iron. So let's take a look at maybe our, here we go, this toggle clamp that we looked at in a different lesson. And we'll put the magnet on here. And there's a little bit of attraction there. So that tells us that this metal just has a little bit of iron in it. And this is probably a stainless steel. Most stainless steels are not magnetic. There are a few, like 17-4 stainless steel, that are magnetic. But most stainless steels are not magnetic or not very magnetic. And that's the case with this. It's just a very loose, you know, it'll fall off if I jostle it too much. And maybe these pins though, these rivets here, these are not necessarily the same material. So let's take a look at that. Oh, much better attraction. So this one, yeah, that the magnet is not going to come off. So these rivets are probably some kind of steel, just a plain steel. Maybe they're coated with something, I don't know. But magnets are attracted to ferrous materials, which usually means just your general steel, and sometimes stainless steel, but just some of the stainless steels. If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.